7. Okay, when you do mean, median, mode, and range, all that, this is you typing into stat, edit. I'm going to go up, clear, down, and then I'm going to type in all of those scores into my L1, okay? Okay, so once that is all in your stat edit L1, you should do a stat calculate one variable statistics. So the mean is the first one, the X bar, 77.64. The median is in the middle, so it has told me the median is 80. The mode is anything that occurs the most. So a couple things you could do. You could just physically look on your paper. I'm not sure if it helps more if you do stat. You can sort your L1, enter, and then when I go back into the edit, I can scroll down and see if there's anything repeated. Oh, I see 2 80s. That's it. So there was 2 80s. And the range, so the range is when I take the highest 99, so max 99 minus the min means that the scores span 50 wide. Okay, fill in these words. So you're either going to put bigger or smaller on these blanks. So if you have a very large sample size of data, then you are going to have a smaller margin of error. The more data that you collect, the better it's going to be. And then if you have a small sample size, you are going to have a bigger amount of error. Okay, confidence stuff. So here's a survey that was given. What's our confidence level? How confident are we in this study? We are 95 out of 100 times confident. So we had a result that said there's 45% of people, but that was within 3% points. So 45 is where we were at, but we have a plus or minus 3, which this is your margin of error. If I ever ask what's the margin of error, it's plus or minus 3. Some of you in your test forgot to put plus minus in front of that. So what is my interval? I can go as low as what to as high as what? 42 to 48. That's my confidence interval. Sorry, where did I get these values? So 45 minus 3. And 45 plus 3. So if there's this many Manitobans, how many can we expect to own home phones? So times this number by 42%. then times that number by 48%. Because on the bottom end, we expect 42% of these Manitobans to have a phone at home, and on the top end, we expect 48. So that's how many Manitobans we can expect. Okay, which one of these data sets is more consistent? So we are looking for a lower standard deviation, because your standard deviation spreads us out over that little curve. The larger your standard deviation, the more spread out you are. So the lower standard deviation is more compact. And then on 5, analyzer findings. Well, these are all very similar, but range is quite a bit different. So what does a range tell us as well? If you have your low to your high is 25 apart, or your low to your high is 12 apart, that would tell us that this is more spread and this is more consistent then. Okay, my class had an average of 80, so put that right in the middle of your chart. The standard deviation is 4, so this person would get 84, 88, and 92. Up 4, up 4, up 4, up 4. Can you also backtrack here? Go down 4, down 4, down 4. Okay, you probably want to copy your chart from your cheat sheet on your test onto your cheat sheet for your exam. So this question is going to use the rules 68, 95, and 99.7. So if this is 68, then this is 34, and this is 34. If this section is 95, then 95 minus the 68, divide by 2, means 13 and a half. Or you can tell that this is 95 divided by 2, which is, this part is 47.5. Okay, I'm going to go 99.7 minus 95. And then divide by 2 means this is 2.35, 2.35. And then 99.7 divided by 2, this is all 90, or 49.85. Okay, so all this stuff you can be copying onto your cheat sheet. And what is exactly there and up? From the middle up should add up to 50. So there's a little bit left there. Right? Because there's 99.7 within the threes, so there is a little bit out on the outsides. Okay, so here's my question. How much percent of the data is between 68 and 80? So this is what I'm doing. So between this -3 and the middle is, and I have that value right on my chart, I can see it. So I've marked it here. So from there to the middle, do you understand the only way you can ever use this method is if your numbers are exactly these on the bottom? So if I say bigger than 77, you can't be using this method because 77 isn't a number on here. Okay, so on the next question, above 67, so there's the -1 that we're at, and above. So for me, I would put a 34 right there. Does that make sense? A 34 is just in the -1 to the middle. What is all above the middle? The whole half is 50. So 84% of the data. Okay, so this next question is below the 72. So this is the chunk that you're looking for. So you can do this in a couple ways. You can do those two intervals added together. You could do the whole half minus that chunk. Okay, how much of this do you want me to do? Good? Get the idea? Okay, that's using your chart. Okay, then I'm going to flip. Okay, finding a z-score, that formula would be on your formula sheet, but you can put something on your cheat sheet if you want to say z equals your score minus mean over standard. Because my formula sheet will probably say like this. So if you want on your sheet, you can put it in words, right? And then you know what you're doing. Your score minus mean over standard. Okay, please, just the general idea, you should understand if you're above the average, you have a positive Z-score. If you're below average, your Z-score is negative, right? Okay, so what is my Z-score? I got 93, the average was 85, and the standard was 5. So I'm positive because I'm above the average. And remember, Z-scores on our chart, most of them are between -3 and 3. Sometimes you might be a little bit out. You might be 3 point something, okay? But most of the time, right, 99.7% of the time, you're between -3 and 3. What is your score if the Z score is this? I'm below 85 because I'm negative. Okay, it's a little bit of algebra, so what kinds of things would you do to get the X? You should times by 5 and add 85, right? Times by 5 to get that out, then move. That makes sense because I'm below the average test score. Okay, determine the percent of data. So obviously these aren't the perfect ones, right? So I'm going to use my calculator. So this is the normal CDF. Finding a percent, you're going to have two methods. One was on the chart. That's only for the perfect scores on the lines. This is not perfect scores on the line, so understand the difference. Okay, so remember that there's 4 parts to this. Do you remember the 4 parts? Low, comma, high, comma, mean, comma, standard. So I'm going to go from the low to the high, comma. What is the mean? This is a Z-score. These are completely talking about Z-scores. So the mean is, what's the Z-score in the middle? 0. And what are the Z-score ticks going up by? 1. Do you remember where your button is? Distribution, so second vars. Second one, just think about cats and dogs. So this one says above the Z-score of 0.6. So you're going to go from 0.6 and above. So now I do the 99999 because I want to go forever above it. So just give them instead of infinity, I don't have that button. I'm just going to do that instead. So how do you do below? So if you want to be below something, forever and ever below, what's the low end? Now you got to do negative 99999 is the low, and then you get up to 2.5. Okay? So just be careful with understanding it's a domain. You always have to say low to high. So it's either negative infinity to a number or a number to infinity. Okay, on the next question it says what percent of data? You're doing the exact same thing. Normal CDF. The only difference in this question is that I don't have my stuff in z-scores. I have my data in actual scores. So above 30, I go 30 to infinity, comma, and look at, there's a mean of real scores and a standard deviation. Okay, so you're doing the exact same thing. The one has z-scores in it, but the other one has real scores. Okay? Okay, and then are you okay if I skip those two? Do you understand the idea? One, it's just repeating the same kind of thing. Okay, number 11, I would say not many of you aced this on your test. So if you're gonna have something for your cheat sheet, I would put this on there. Or I would really put down this is what I would do on my cheat sheet if I want to find a percent. So if I want to find a percent, there's two things I'm either going to be doing. It's either this if it's perfect or this if it's not perfect. So again, I might give you z-scores, I might give you real scores, if you want to write that down. And if I give you the percent and then you want to get back to the number data, so these are the opposite things. I give you data and you get me percents. This time I give you percents, you get me the data. You're going to do this inverse norm. And here's the thing, lots of you didn't remember this one, below. You always have to use it below, the decimal below. And your calculator will give you a z-score. Then if you have a Z-score, what can you do? Figure out your score. Okay, does that make sense? That's a good cheat sheet little summary if you want. Finding percents, you either got those two methods, given a percent, inverse norm below, get a Z, take a Z, put it into a formula. Okay, so 10% of data is below what score? So I'm going to inverse norm. So again, that's under your distribution button. Distribute data, inverse norm, 0.1. That is a Z-score. Now I want you to turn the Z-score into an actual score. So you're going to have to do a times add. Always that. Times add. And it's actually right on there still. So I can do times 2.6 add times by the bottom and then add. Okay, I'm going to skip, just for time's sake, we're going to do C. 15% of the data is above what score? Okay, so you are not going to put 15 in here. This isn't 15. What would you put instead? Because this isn't anything with below. So what is below me? If I'm here, what's the below? Would 85% be below me? So I'm going to go 0.85. Okay, that gets me a Z-score times and add. Z-score on my calculator times add. I swear it's coming from, no, it's coming from that side. It's totally coming from there. Okay, one more page of stats. Okay, so my plan is quadratics all day tomorrow, and then on Thursday, we'll do the last 2 units. Okay. Okay, track and field discus throwers, and so this is going to be a frequency table. So you're going to have to say who threw between 70 and 79. So I'm going to go 1, 2 people. Who threw anything in the 80s? 1, 2, 3. I got 3. Is there 4? Yeah. 4. There, I found it. 4. How many people threw in the 90s? 1, 2, 3, 4, 5. 100. 1, 2, 3, 4, 5, 6, 7. The 110s is 1, 2, 3, and 1. Carlin. Is that you? You're the 1. Most improved. Throw in the hardest, right? Okay. So we're gonna graph this. So I need a title. So then discus throws. We're going to say the distance at the bottom, because that's what we're talking about, and the frequency at the top. Okay, so some of you on your test did some weird stuff on your x-axis, okay? If you can start at 0, start at 0, but this doesn't make sense to start at 0 because I have a big gap, so I am going to just leave a little space, and I'm going to go 70 to 80, 90, 100, 110, 120, 130. Okay, so you need to make sure you have everything labeled there. How many throwers were in this competition? So you could go back and you could count all those up. Or even faster, just total this. 2, 4 is 6. 5 is 11. 18. 21, 22. 22 throwers. Would you say this is normal distribution, yes or no? I would say yes. Why am I saying yes? Because the shape is that there are more in the middle and less on the outsides. That is the pattern, so that's making that shape. Okay, we're going to find the mean, median, mode, and range using the frequency table. So when we're going to do our stat edit, what's important is that you use the midpoints. So we're going to use these numbers. You don't have to write this down. I'm just showing you. This is what I am typing into my stat edit. Okay, so I'm using up L1 and L2. Okay, so when I'm doing my stat calculate one variable statistics. I'm going to go L1 comma L2 so that it uses both of them. So basically what am I doing? I'm typing 275s in there. I'm typing 485s into my data. That's what it's going to deal with. L1 comma L2. You need that in there. Okay, so my calculator data, well, 98.64 was the first thing. Median was on there. For mode, you can either say this interval or this midpoint. I don't care. One of those I would accept. Frequency range. And I should have written this out. I also want you to write down the standard. Can you write that down on your screen? Because you're going to need it. Okay, so a throw of 95 feet is what Z-score? So how do you find Z-scores? Z equals my score minus the mean over the standard. I am negative because I'm below the average throw length. Negative 0.28. Okay, what if I ask you what percent? What kind of things are you doing if I say what is the percent of data? You're doing the normal CDF. I want you to be under 80. So what's the low? Low to the high, comma mean, comma standard. Okay, I'm going to change this question. How many throwers threw between 100 and 120? Okay, I do not want you to go back up to the top and count them. We're not doing that. I'm going to show you how to do this with percents. So you're going to figure out the percent. So what percent of people did this? So between 100 and 120, comma mean, comma standard. Because this question on the test, not a lot of you got. So I got 40.84% of the data. then times it by the 22 people. So this percent times the whole 22 people means that there was about 9 throwers in that zone. Okay, so does that make sense? How many? I'm not asking you what percent, but you're gonna have to get the percent to get the answer. Okay, last question of the day. 80% of the throwers threw at least what distance? So then I'm asking you that 80% are below what distance? So if I give you a percent, what are you going to do? Inverse. You're putting in a decimal, and this decimal is showing me below. So in this case, it is a 0.8. If it had been the other way, you would have had to do a 0.2, right? Sometimes you got to figure that out. So is that my distance that I'm throwing my discus? No, that is a what? Z. So what is my score? So just the Z score formula again. Go from a Z to your score. So times, add.